Now let's try to apply these definitions to some geometric figures. So in this triangle ABC, where we do see that one leg has been extended, we need to identify two acute angles. So we're looking for two angles that are less than 90 degrees. You have an angle up here at vertex B, and you have an angle here at vertex C. In order to name those, we need to find the 3 points that define a particular angle where the vertex is in the middle. So we can start at A, go to B, and then go to C. So that would be angle A, B, C. And then we can get the angle there at C by going from B to C to A. The right angle is going to be marked with the little square, and we see that here at A. We would label this BAC, or you could label it CAB. It's fine to flip the angles. Supplementary angles are going to be two angles that add up to 180 degrees. You'll often find these in a straight line. So if we look at this straight line here, we have supplementary angles there. So we can label one of those BCA, and that's going to be the angle on the left, and then the angle on the right would be BCD. Notice that they do share a line in common, and so that's why we do have two of those letters in common. Now, complementary angles are going to be two angles that add up to 90 degrees. And even though we don't have any angles here drawn within a right angle that you can see, I do want to point out something about these triangles. Since every triangle has a sum of the angles that will add to 180 degrees, since we know one of the angles here is already 90, then the remaining angles have to be 180 minus 90, or 90 degrees. So it doesn't matter what B and C equal, but we do know that when we add them together, they'll be 90 degrees, which will make them complementary. So here, angle ABC and angle BCA will be complementary. Now in the next example, if we know that a particular angle is 36 degrees and we want to find the supplement, we're looking for the angle that when you add to 36, it will equal 180 degrees. The easiest way to find that is to take 180 minus 36. That's going to give you 144 degrees. Now the measure of a complement is going to be 90 minus that. And so here we would have 90 minus 36, and that's going to equal 54 degrees. And then the last example here is we're looking at this tract of land here, and we have the angles given. We know that this lot is rectangular, and we need to find the measure of several of these missing angles. So let's look first at DEC. So that's going to be this angle right here. Since that angle is vertical with the 120, you see that they have these intersecting lines and they're opposite, then I know that angle DEC will have to also equal 120 degrees. Now let's look at angle CEB. I want you to notice here that CED and CEB together form this straight line angle. So whenever you have two angles that form a straight line, you know that they have to be supplementary. And so angle CEB will be 180 minus the 120 that we just found, and we get 60 degrees. I could have just as easily made this a supplementary angle with angle BEA. Now let's look at ECD. This angle is up here, ECD. And even though it's hard to see this, I want you to realize that opposite sides of a rectangle are parallel. And so we can actually consider this line AC to be a transversal. When we do that, we see that this angle that we're looking for is an alternate interior with the angle there marked 30 degrees. because they are on opposite sides of that transversal and inside the parallel lines. Alternate interior angles are congruent or equal, so that will also be 30 degrees. And finally, angle DAE is this little angle down here. And we see that this is in a rectangle, and so all four corners are going to be 90 degrees. So DAE is going to be complementary to the 30-degree angle that's shown there. And so we can find that by doing 90 minus 30, which gives us 60 degrees.